program has this program has been sponsored by AICTE, which is the highest body looking after the technical education. And AICTE has one initiative that AICTE Training and Learning Academy ATAL initiative, so under which we are conducting this program. The title of the program is 21st Century Materials, Advancements in Material Science and Technology. We are conducting this in association with ASM International Pune chapter as well. So on behalf of Varshi Karve Sri Shikshan Samstha and Cummins College of Engineering for Women, I welcome Dr. Vijay Nimbalkar sir for this session. So today's session, apologies that the topic is mistakenly written as a ceramic, but Dr. Nimbalkar will talk on the various materials required for advancement in defense, or the advancement in materials required for defense application. So let me introduce Dr. Nimbalkar sir. Sir is a scientist at Naval.
Excuse me, sir.
Huh?
Excuse me, sir.
Yes,
Sorry for the interruption. Sir.
Hello.
Sir, high level of echo is there.
High level echo. Nikhil?
Resounding, sir. Sound is not clear.
Sir, now it's fine?
It's okay. Fine. It's clear.
Nimbalkar sir? Now it's fine. Now we have Dr. Vijay Nimbalkar sir, who is a scientist at the Naval Materials Research Laboratory, Ambarnath, that is in Mumbai, near to Mumbai. Ambarnath is a separate place, which is nearer to Mumbai, DRDO. With effect from 1999. He has developed several components to naval, defense, aerospace, space and automotive applications, especially in the indigenization and development of SSM technology, metal matrix composites, flameless portable heating, steel strip laminated process technology source are some of his expert area, and he has developed many systems based on this. He was a project director for the development and indigenization of weld consumables for yield strength more than 690 megapascal grade steel for submarine. He is a recipient of many awards like Best Paper, Best Poster Presentation at various occasions. And he has published more than 25 technical papers, and three patents are credited to his name. He is also members of Institute of Engineers, Kolkata, and CIA. So I welcome you, sir. Your topic here on the screen, the topic is it's a typo mistake. Your topic is the advanced materials required for defense application. I request Dr. Nimbalkar sir to proceed for your with your presentation. Thank you. Sir, now you can share your screen. Sir,
hello.
हाँ sir.
तुम्ही प्रिया विजय निंबाळकर, you have to share.
तुम्हाला co-host एक मिनिट.
Share.
सर तुम्ही शेअर करा, तुम्ही होस्ट आहात काम, तुम्ही एक मिनिट सर,
कोण?
एक सर प्रिया निंबाळकर यांना पोस्ट. Now you can do, sir. Now you can do. Ha, perfect. नाही तुमचं प्रेझेंटेशन. सर खाली प्रेझेंटेशनच्या आयकॉनवर हे करा ना, म्हणजे तुमचं स्क्रीन शेअर झालंय. हा नाही नाही सर, एक काम करा, हे बंद करा आणि तुमचं पहिले प्रेझेंटेशन ओपन करा, म्हणजे हे क्लोज करा आणि प्रेझेंटेशन ओपन करा. हा हा नाव इज फाईन. आणि स्लाइड शो मध्ये जा सर, इथे खाली स्लाइड शो. येस परफेक्ट सर. आणि आवाज फक्त तुमचा आता म्यूट आहे.
ओके. ऑडिबल?
येस ऑडिबल.
ओके.
पार्टिसिपेंट्स इको येत आहे ना. पार्टिसिपेंट डू युअर इको.
Okay, can I start?
Yes.
Okay. So thank you first of all provide these opportunities. First of Prasanna sir and principal of Cummins College. I am associated with long back, one of my scientists in your organization, Joshi sir.
Yeah.
And Madhuri sir, madam in Pune.
Kambete madam. Yes.
So every year I got 1 or 2 admission in your Pune campus, and I would like to thanks whatever the admission I did in your campus at Pune, all the students got it a good job in Germany and other countries. So that is a good atmosphere, Nagpur as well as Pune campus. So I will start my presentation.
Yes sir.
So I belongs to DRDO. So just I will share some slide initially. DRDO. So DRDO is a basic defense research development organization. We have 52 laboratories all over the world. Out of that, NMRL, Naval Material Research Laboratory at Pune, at Nagpur, Amarnath. And our main motto is to carry out design and development of component, not in pilot scale, only in a R&D basis, meaning basic science. So that is the DRDO mission. After the completion of these R&D, we have to convert that product into the final shape or commercialization with the help of industries and academia. So first is analytical system and missile strategy. So our analytical systems laboratory, it is found in Bangalore region. They have a lot of 4 or 5 laboratories in Bangalore, and they have successfully developed Tejas LCA. Tejas LCA is a unmanned aircraft, and Tapas BS recently one trial has completed, and Nirbhaya also. All these aircraft developed, indigenized, and submitted to the army. Second one is missile strategy. These missile strategies only basically for Hyderabad region. They have 4-5 laboratories, DMRL Hyderabad, DRDL, RCI, and AFL. So all laboratories are working on different type of missiles, Prithvi, Akash, BrahMos, and our past chairman, Dr. Abdul Kalam ji, and our Rashtrapati, he belongs to RCI. And today he has means a new version of missiles has coming in the country. One is Astra and BrahMos. I would like to say, as a glad, one of the best missile in the world, we are found 450 kilometer per distance, BrahMos missile. And not only India, the other country also asks these missile for their purpose, means missile army purpose, because this is the only one missile is having a supersonic capacity. Other country and India also, all the missiles are not supersonic. BrahMos is detect the enemy or submarine inside the water. So that is a good research done by DRDO. Then electronics, communication and system. It is also in Bangalore region. We have developed a lot of radars, electronic optic system, communication system, and mostly radar is working, and lot of the laboratories presently working on solar system also, because radar is only for normal atmosphere, air atmosphere environment, but submarine not detected by other devices. That's why 2-3 laboratories also working on solar system, and they are also successfully developed. And due to that, BrahMos can attack directly enemy and inside the water. And second is armament and combat system. It is very close to our place, Mumbai. And your belongs to Nagpur. Okay. So that is armaments division. They have developed a lot of gun barrel and a rail gun. Another one is Pinaka rocket launchers. Another one is tank, Arjun tank. So, and second thing is INSAS Banduk. These are the work done by our sister concern laboratory, ARD Pune, as well as HMRL. Then naval systems. My laboratories belongs to this area, naval system. So we have 4 laboratories. One is NMRL, NPL coaching, DMRL Hyderabad, DRDL, and DMSRD Kanpur. So all these laboratories are near to the cluster area, dockyard or shipbuilding area. That's why we are in naval clusters. So I am also developed these torpedo advanced light materials, solar also developed by NMRL. And I glad to say that all the submarines is having presently battery system. So NMRL is the big project, 2,000 crore project. We are working on the AIP, air induction propulsion system. In that, we can replace that battery unit and feed our fuel cells as a energy generator. So we can save a lot of money of government, and we are already in pilot scale. We are transfer the technology to L&T Hazira Surat, and maybe one of the submarine recently Kaveri or Karan Scorpio submarine, France based. So we will put this AIP inside that year. So all this problem will solve shortly. So it is not research, but as a academia, I have added 4 or 5 slides for your purpose. So sir, in our DRDO, there is some boards are there. One is armament board, naval board. So armament is basically for armament applications. Those are working in radar, sonar, some materials, electronics materials, controller, capacitors. So this area is under armament research board. So I have already mentioned the name of persons. Those are in looking in ARD Pune. So KD Dhote. So you can approach, and I have already shown in slides what are the procedure for getting the project from DRDO, Army Board. So you can approach. I have already mentioned the DRDO headquarter address as well as local address also. That is the better opportunities for mechanical and electronics. Then another is Naval Research Board. It is my laboratory is under this laboratory. So we have a lot of requirement. I already mentioned in my slides what are the new requirements is required. So you can take the supports from your fourth year student or third year student, and we will get the good opportunities from DRDO. So naval research, mostly materials development. So you can develop the composite materials, some high entropy material. Today is a new version of material, naval material called high entropy, complex concentrated alloys, and some forging materials. Mechanically is a point of view for high strength material for submarine construction, ship construction. So you can think and you approach these address persons, put up in 1 or 2 page write up, and they will send to respect to laboratories. Those are working on this area, and we scrutinize and will provide the whatever the cost and you have to present in NRB board. They will provide the date and you will get the project. 25 maximum capacity may be 1.5 crore, 1 crore, but 25-30 lakhs it is in our hand. That is Ornament Research Development Board. It is mostly Bangalore-based laboratory they are looking. So those are working in mechanical and automobile or aeronautically engineering. So you go through that laboratory, what they are working in the area of aeronautics, and you can approach directly or with the help of 2 page write-up, new things. So they will provide the project. Then this is the good things for academia and industries. So this is a technology development fund scheme. Recently, Modi government has announced, and in this technology development fund, they are providing 15 crore rupees. So 15 crore rupees, but there is a involvement of academia, DRDO, and industries. And academia parties, they are carried out the simulation and modeling and some basic research, their premises. After that, they will ask to company to convert this basic science into the product. So that you want to take the help from industries. And third one is the DRDO, whatever the lab, you can approach one lab as a user. And after successfully developed, you have to deliver this component to the Army, Navy. And this is a big opportunities for academic. So today is my topic, advanced 21 means materials for the 21st century. So first I would like to tell what is metallurgy and material science. The metallurgy is a process that extraction of metal in their from the pure form. So metallurgy means whatever the rocks inside the land, you have to taken it from land, roasting, smelting, then carried out some ingot. So that is the procedure for metallurgy. But if you successfully carried out the melting, casting, roasting, smelting, then you have to characterize the material. What are the purity of material? What is the strength of material? What are the performance? What are the life of material? So that's why material science is required. So material science is basically they are involving restrictive and non-restrictive testing. Non-restrictive testing is after product form, and restrictive is before. So basic characterization, we require chemical analysis, tensile strength, impact strength, and fatigue strength. So that is the material science difference between metallurgy and material science. So I would like to first materials we have developed, low cost, high capacity field ration heater. It is a basically started from America, magnesium and iron. You see, it is a patented technology from USA. I have only taken this magnesium and iron, and we are adding extra aluminum. And with this patent, they have mentioned the heat contain and heat release -5 degrees Celsius materials convert into the normal materials. It is taken 12 minutes time, and temperature is around maximum 62. But in our case, this is the patented technology, aluminum, iron, magnesium 5% iron, and they have some polypropylene cloth and puts that materials. So we have taken these patented here, and we have carried out it NMRL. So here you see the 220-gram materials we are using for 30-gram pulao, ready to eat meal, and that is a requirement come from army. Because in army, there is in winter session, there is the outside temperature is around -35 and 40 temperature, and they can't eat properly. They took one piece of rice, whatever the ready to eat provided by our government. And second thing is that aircraft also not landed in winter session. So how to pre-cook pre-cook material convert into again into ED2 ready. So that's why we have developed this technology. So instead of that magnesium iron, we are add aluminum, and this is the exothermic reaction. And there is a requirement of formation of microcell, means layer by layer material. For that we are using ball milling, and we keep this aluminum, iron, magnesium up to 14 hours in that ball mill, and after that we screening this powder and using for this application. So cost benefit wise, this is the USA material, magnesium 5% iron is 1 rupee, and our cost is Indian cost is 0.39 rupees. And this material is, you see here, only 2-gram material, we add 2.5 ml water, you will get 85 to 95 temperature. And initially temperature of material is -5. So we are using this material for 28 gram for 300 gram pulao, though easily available in the ready to eat meal. And those provided by our government to our soldiers. And we are carried out -5, 0 degree and 5 degree temperature. And this is the graph is showing the -5 temperature reach into the 85 to 95 temperature within 15 to 20 minutes. It is close to our pressure cooker temperature. This is the good thing. After that feasibility study we carried on laboratory layer. We converted these means demonstrate the trials at K-top. It is the highest height in seawater, 3,000 something. So we demonstrate these are the kit, this is the reusable bag, this is the heating pad. You see here, there is a powder we are put 4 number of packets one side and 4 number of packets. And another one, 2 heating pads using for 300 gram pulao. We put into this bag, aluminum bag. We add just 50 ml water. After adding the water in both the side, 50 ml in one side, 50 ml in another side, you see the soldiers are doing the job. And within 15 minutes, they got more than 85 to 90 temperature. And this trial we are successfully carrying 18 feet above the MSN, Miss Kardung Lata. It is very close to China border. And we demonstrate this technology, our Jawans, our soldiers, and our officers also, naval officers also. And they are very happy. They said they wrote one letter to DRDO. As per the government norms, every 3 years, they transfer into the another troops. But after this successfully development, the new materials, they said we can not shift it to anywhere. We will continue for nations on border. So and we got this 5 lakhs award from Vajpayee government for this work. Then during our demonstration, some military officers are visited. So we also demonstrated that technology to that and military officers also. And same after these army and naval applications, we want to check this commercial application of this product. So there is a outside temperature is minus 35 and 40 degree. We have keep some puris and potatoes, and these puris are put in these our heating pad. Add 50 ml water both the side, 50 100 ml, and you see here in K top we found there is also 20 minutes, some temperature is around 80-85. So that is also successfully. And another one application of this product, diesel fuel tank. Actually, before this product developed, our soldiers are keep their vehicles full night start. If they switch off the vehicles, so frozen of these diesel, how to convert that frozen diesel into the normal liquid. So that's why we are developed. They are using some grass also, and we have found sometimes they are putting some grass on the tank and burning on the top side, and some accidents also happened. But after using our heating pads, you see here the minus 50 degrees Celsius converted into normal liquid without adding any chemical inside that diesel tank, and their problem has solved by this technology. Second, in midnight, we have carried out, this is a ice pot, chapatis and dal. So they have given another one task to 11 feet Karu EJ1 troop is there, and they asked to DRDO to carry out trials on Karu at midnight. That time temperature is outside is around 30 minus 50 or minus 45, and this time we are not adding the water. Whatever the ice is outside, we crush the ice and put on our heating pads. So you see the -7 initial temperature converted into the normal room temperature, 54 degree and 56 degree. So that is also very helpful for our soldiers and officers also, naval officers. Then sir, there is a biggest problem. They are applying IV fluid to our soldiers in their medical treatment. So outside temperature is very low. So our IV bottle has frozen. So there also they ask you can utilize our this composition of this material, magnesium, iron and aluminum, for converting that solid fluid into the liquid. But problem is here, our temperature is 85-90 degrees Celsius, and they want, there is some restriction, our body temperature is maximum 39 or 37 degrees. So how to maintain this fluid body temperature, fluid temperature around 37 to 39, but longer duration. Because saline has applying not for 1 hour, it is a continued 2 hours or 4 hours job. So we are adding whatever the composition we have developed, we are adding normal riti, sand, river sand, and we are Na2SiO3, and we reduce that temperature 85 to 36 to 39, and we carried out the trial at laboratory. You see that -5 temperature will keep for 4 hours, and there also that problem has also solved. And then there is we are found our soldiers have not taken the bath, maybe 3 months, 4 months also, because they doesn't get the water. So you see there is some problems. Fingers is appearing just like forced bite. And second thing is also some fevers also, forced bite and other disease also coming. So they asked to develop some product for avoiding these forced bite and other disease, Chalipian. So we are that saline fluid composition. We are keeping some tissue, wet tissue inside the leg, between leg and shoes. As soon as pressed by legs, that tissue paper immediately starts the reaction, and heat will be coming slowly. So that is the advantage that our soldier get some heat, 39 to 37 degree up to 4 hours, and they can war continue. So that is the one thing. This is the setup actually, and we are patented, American patent also and Indian patents also for this technology. So this is the technology we have developed and successfully transferred this technology to industries in India for this product only. Heating pouch, saline bottles and other purpose for army purpose. But another, they have some requirement, body warming for soldiers, and they have initially some Bukharis, but that Bukharis is kerosene based. So whatever the kerosene Bukharis are having, so top of that Bukharis is open. In winter session, some snowfall, and that snow is fall on that chimney, and entire carbon dioxide has coming back, and our soldiers had died. So for that, they want same technology utilized for body warming. So my request to academia to take some student and carry out this work for your premises or with the help of industries, means TDM, technology fund, or directly in the NRB project. Because we are already involved in some other activities, so you can take this opportunity. Then another one is recently we are found lot of fight about some that guy go Vansha. So there is some foreign country, Singapore. They have provided one kit. He identify the meat. It is a guy, cow's meat or another animals. So they have some water, 20 ml water in that kit. But their requirement is they have to carry out some 50 degrees temperature of this water bottle. So they ask, Singapore person asked to NMR to support this activity, but at some point of view means other country and so that's why we are not supporting. But you can take this opportunity, you can make the powder at your premises and you can do it. So that is the from this activity. Another activity is semi-solid metal processing. In these, actually, maybe in your presentation, previous presentation, you have seen lot of composite materials, lot of rolling materials, forging materials, casting materials. So we have to develop this material for aluminum technology, aluminum process. So in this technology, normally the people are carried out rolling. First is melting, then billet making, then extrusion, then forging, then machining. The very lengthy process. So this is the beauty of this technology. We are made this material in a very low temperature. Aluminum melting temperature is 650, but we have carried out this process, aluminum alloy, in a range of 16 to 630 only. And with that temperature, we press this material is high bar, around 2000 bar. And with that 2000 bar, there is no single porosity we are. And this also technology we are provided to one of two company. One is Omar and Bagla. It is a Italy-based company in Aurangabad, and one is AICTE Attal at Gurgaon. So this is a good technology. So only, but this material is not, material is not processed pure aluminum. We require alloy, aluminum alloy. So we will tell you the detail of this technology. You see here, this is a pure material, cooling core. Metal is started from cooling. This is the liquid, then cooling. It is a single process step. And you see here, there is a two-stage material. Here is a material is in liquid stage. Here is a solid. So whatever the range is there, means liquid solid fraction is there. Those alloy can use for this technology. That is a challenge. And second thing is that solid liquid to solid, there is some requirement of time also. If we carried out some processing, the material not should be frozen. Otherwise, the entire thing will be choked. So that is the challenge as a scientific. So this is the SSM, near net shape casting, and essentially this type of microstructure is required. Whatever the presentation as a metallurgist, आपने सुना होगा. So there is a dendritic microstructure. Whatever the presentation previous, so we have to convert the dendritic microstructure into the globular microstructure. That is the challenge. And whatever the material we utilize for this trial, that material should cut just like this process, just like tomato, pads, we cut in your house. Such type of cutting is required. And this is the dendritic microstructure. Normally we found in the all materials. So we want to convert in the globular shape. So this is the procedure actually. for converting that dendritic into the spherical shape. And this process is discovered by MIT in 1971. And it just the origin is butter and toothpaste, normal our house. So that is the taken the help for this technology. So there are the three-step process. First is slug, whatever the material means alloy, aluminum alloy we have developed 2014, 6061, 6063. So that is developed by NMRL, and we have developed some aluminum alloy high strength for naval platform. So we cut in the some shape, reheating by induction heating, then into the semi-solid stage, then we transfer into the die. So you see there is a liquid solid material and time. So this is the diagram we require for the calculation. If what time we start this means rotating electromagnetic stirring, and what time we have to stop, and time also. So with the help of we taken this, we generate this diagram, phase diagram, and we carried out the experiment at NMRA. And normally this is the lamellar flow is required. Normal, whatever the material in your utensil or normal market, whatever the aluminum, steel, as well as there is a not lamellar flow, it is a turbulent flow. That is the difference between our materials and normal material. So quality wise, our material is very high, very good material. There is no any porosity, and surface finish is good, and intricate shape. You can make 0.001 mm thickness sample. So this is the application. Lot of application for this technology, and advantages is excellent mechanical properties, pressure tightness, reduce the finishing cost. Because this is the one-stroke process. Whatever the component is developed by this technology, you can utilize this product directly into the final application. So this is the machine first time in India. It is a 2 crore machine in NMRL, and we have developed lot of component by this technology. You see, this is the globular structure, and normally in commercially available A356 material in market, it is the strength is around 200, 250 or 200. We got it by this technology 320, 350. And major beauty of this technology is elongation. We found this elongation is 20%. Normally, the material aluminum and maximum ductility is around 8%. So that is the beauty of this technology. And you see, I already told this is the normal component. Whatever the component made by die casting process, you see here lot of porosity. This component is used in our petrol pump by commercial application L&T. So same they ask NMRL to carry out kind support for making this component without porosity. So you see the downline, it is our process component. There is no single porosity. And this component also withstood at maximum 5 bar pressure. And another, this component is for Russian engine, for ship. So here also we have carried out initially some simulation modeling. And after that simulation modeling, we identify the temperature, what is the solidus and liquidus temperature. Then we carried out the trials, and we successfully delivered this component to the naval for ship and as well as missile application. So in this process, there is some disadvantage. One is billet making. After that billet making, we have to cut the material in limited shape, and we again you have to carry out the reheating, and there is a restriction L by D ratio. Your material should be within a range. If your length is more, then after reheating, your slug will be broken in middle. One disadvantage, major disadvantage, and third one is how to transfer this material into the sleeve of machine. Because there is a temperature of 700 degrees Celsius. If you putting some high temperature gloves, so there is some problem for our workers. So there are lacuna in this technology. So NMRL, as a scientist, we convert way forward into the some liquid state. Directly pour the liquid, and within that range, we convert that material into the primary spherical shape and make the component. So that is the technology we have developed. So you see here the new innovation is required. we have made only for aluminum alloy. You can think copper base, iron base, and nickel base. You take these opportunities from NRB board, you propose, and we will support you for providing our machine facilities, not only in our NMRL, ISCS Bangalore, and other private industry, one or two is having 8. So you can take the help from them also and carried out some good academic basic knowledge for copper base, iron base, and nickel base material. So this is the new ray casting. So in this case, no need to robotic transfer. There is a robotic transfer is required, and alloy modification. Yeah, there is a, if you carried out the experiment one time, if you can make the component, second time again you have to carry out the globular spherical shape powder. But in case you can no addition of you can add, if you want to make the alloy as per requirement, you put whatever silicon, magnesium in that furnace and you make the alloy. So that is the one advantage. And alloy modification you can also done. And there is no restriction of material. There is some L by D ratio is required. Here is a no restriction. And second thing is recycling. There, if you recycle the material, your entire properties goes. And here, there is a no properties which collapse. Whatever the properties you are getting in the final component, edit it. So this is a cooling slope made by NMRL. And we pour this material, this end, and this is the length of this cooling slope is around 2 meters. And with initial temperature pouring is around 630 degrees Celsius, and we got it that material and then other side is around 590 or 595, and we made, you see, these are the initial microstructures and revo casted material microstructures. It is a very good microstructures we are found, very clean microstructures, and everybody knows Sunita Williams, he has found some problem for electronics packaging material. It is called as standard disease component ISRO. So ISRO also facing the problem. You see here, there is a 2 mm thickness material, and normal machining, Z axis, Y axis machine is not feasible by this for this process. So they approach NMRL to carry out some component. So we are made the die and simulation is carried out, and we are successfully developed this component and provide 100 number of component of aluminum alloy A356 to ISRO, and they are very happy, and regularly they are used this component also. And our BrahMos, I already explained. So it is a clamp component they are using for joining of these distributor together. So there is a hot gas is there. So they are making this component by machining process, means melting, then billet making, again forging, then machining. They took 3 months time for 2 components. In our machine, we are provided this 2 component within 20 seconds. And their requirement is 275 yield strength. We are provided 284. And elongation is 10%, 8.4. And hardness is also more. And these component 100 numbers we are provided BrahMos. They are successfully carried out the trials, and after that we relay the technology and transfer to these 2 company in India. And this is regarding to new materials, zinc aluminum. So ordnance factory, all the ordnance factories are working on these Jamat 5. It is a zinc based material, zinc 90-95 zinc, and remaining is aluminum. So they are facing a lot of problems. Whatever the process they are utilizing for making these materials, they found a lot of porosities and lot of segregation on the surface of the materials. Then again, you see their materials, they into the shape, and they found a lot of porosity. And same materials we have taken from ordnance factory, and we have developed at NMRL also. It is an armor piercing discarding. It is a weapon system. You see, it is a weapon. So they have some locking system. They put this zinc aluminum rod. As soon as temperature is reaches, that rod has melted due to the low temperature. of zinc, 440 or 450 temperature. So we carried out a lot of experiment at NMRN, and defect-free product we are transferred to the company, all the ordnance factories. And main thing is they are put these material in these application of this component and successfully, and enhance the speed of this product also. They are initially the product is around 120, 140 kilometers. After that, using this our product, they targeted 180 kilometers enemy. So these are the new materials, new process, and application wise is already found in our army, navy, and with this, with thanks. I am also another materials. I will tell you some explain in for academic purpose. Recently, we are working in high entropy materials. So you can think these high entropy materials because normally the entire material is base material is 95% is iron. So instead of that, 55-60% iron is required. And academia, you can start this work. Very limited persons are working in this area. Third, another one, new materials is coming. Complex concrete alloys and frictional steel welding. These are the new areas. So you have to think and you approach 4-5 students. Because as per our Prime Minister motto, they said ki 4-5 student and academia involved in the research. So please don't miss these opportunities. And maybe this presentation is faculty purpose. So may I request to all the faculty, those are interested to carry out PhD. So we have a lot of equipments better than IITs. So you can utilize that facilities for your PhD purpose. And once again, Prasanna sir for providing me opportunities. And one day I am coming to my native place. That time we will give long lectures. Today also maybe 5:45 another one meeting is there online. So I will finish. Thank you. Any questions, please?
So participants, the forum is open for question answering. If you have any question, please ask.
Good evening, sir.
Good evening.
Sir, a small comparison. What is the difference between Rio casting and semi-solid metal processing?
Actually, there is a thixotrophy. There you can make the casting, make the billet, then again cut into the creating at semi-solid stage, and then press into the mold, and you will get the intricate shape component. But in this technology, the slug is required some 3 processes for making this spherical shape. One is adding some chemical, one other is mechanical stirring, and third one is MSD, electromagnetic. So only one process in the world, one company in Australia, SAG, they are carried out that electromagnetic billet making. So, and second thing is there is a restriction of L/D. But Rio casting, you have to put the material in that cooling slope on top side, and angle of this cooling slope is 21 degree. So whatever the material you pour on the top, the opposite side is some shear force reaction is there, and convert that dendritic into the spherical shape. And you will get there is no restriction of liquid materials. You can add 2 kg, 5 kg, but in SSM you can use only restriction of materials. If material is higher side kg, then your L/D ratio is the issue.
Okay. Thank you, sir. Thank you very much.
Any other question? So I think, sir, we should conclude because you also have another meeting, right?
Hmm.
And already through this program, we actually we got connected, and the faculties also got connect with me. So definitely, if any question or any engagement will be there, faculty also directly contact you, and I am also there because being a coordinator, I will be there.
Hmm.
Uh, if any such query, any such comes to
Nandi,
me, I will let you know.
I will share one video.
Okay.
Just a minute.
The premier R&D organization we need to provide cutting-edge technologies to ground make them invincible at all times. It's a base where patients are moving to get some state-of-the-art technology. Is not the development, it's just the vision. We challenge the area by area terms and research. Daring and standard out of the ideas. Our topographical areas we see types of engineering so the Indian Ocean, we embrace the diversity. Might be the of the country to give it as a key empowers its scientists with opportunities to work in these technological domains of technology and technology, AI, creating systems, and their being and will run all defense ecosystem. The opportunity to work in one
Hello. Hello. Hmm.
It got hanged somehow.
Yes, I think. Nimbalkar sir.
Maybe some connectivity issue from their end.
I think he was playing video. Video requires large bandwidth. Okay, anyway. Sir, Nimbalkar sir, are you there? Anyway, Nimbalkar sir, I think is joining. Dear participants, almost we are done with all these sessions. I am very thankful for joining patiently these sessions. Now, last two things are remained. One is feedback, which you have to give online feedback. Online means in the Zoom meeting. So, valedictory and feedback we will conduct immediately after this. So at 5:45, we will, because since there are 3 sessions in continuation, shall we take a break for 3 to 4 minutes? For 5 minutes. Okay, yes. The participants are saying we should take a break. So anyway, we will you be there. We will restart at 5:45 for the validity and feedback, and there I will give some instruction. Okay. So we'll meet at 5:45. 5:45 for validity and feedback.